Now, let's think about the relationship between the linear polarized light and the circular polarized light. As we've already studied, you can see that the one of the polarization is phase shifted power 2, and then they are synthesized with the EY, becomes a circular polarized light. And depending on the phase is forward or backward, you can control the right-handed light or left-handed light. And because as you can see that this one equal E0 cosine KZ, and this one is equal minus E of 0 cosine KG. So then, if you sum up the electric field of right and left circular polarized light, right? Please think about this. In this case, you could obtain EX equals 0 and EY equal to E of 0 sine KG. So meaning that EX disappeared. So right-handed and left-handed one summed up, the EX field in the X direction disappeared, and then only the EY field remains, and becoming the linear polarized light. So as you can see that linear polarized left and right circular light. So they are just a phase shift combination between the circular polarized light and linear polarized light. So by using this, we use two of the important spectroscopic techniques. And if you use the circular polarized light, and if you observe the refractive index difference depending on the rotation direction for left-handed absorption and right-handed absorption, left-handed refractive index and right-handed refractive index, which is called, this is optical rotation. So some of the chemicals gives a different refractive index for the left-handed and right-handed light. That gives the final output of light, the final output light rotated. And if you observe the absorption difference for the left-handed light and left-handed light and right-handed light, which is called circular difference. And which is very frequently used for many the biological molecules, and they have a different absorption for different rotation light, circular polarized light.